So in this video, we're going to go through some of the challenging questions from the 2019 VCAA exam, looking at recursion and financial modelling. Okay, so the first question here in the multiple choice from exam 1, we can see just over 53% got it right. So trying to give you some strategies about how you would approach a question like this, because it's quite common. So we have a machine purchased for $30,000. It produces 24,000 items per year, and they're telling us here that it's been depreciated using the unit cost method. Okay, so remember that is a linear style. After 3 years, the value of the machine is 18,480. What would be a rule to determine the value after n units produced? Okay, so a couple of things. We need to ensure that the general rule that we're seeing here in the options is the correct style. Okay, so we would be wanting to see something along the lines of the value is the initial value minus the depreciation per unit times n for the number of units. Okay, so even just by doing that, we can see A is not an option. B is not an option. It's not written correctly because we're talking about the initial value is 24,000. Oh, sorry, the units is 24,000, not the initial value. So we would need to see something, what we know so far, the initial value, 30,000, times whatever the depreciation amount is, times n. Okay, so that leaves us with 3 options here. I would also safely say that C is incorrect because 24,000 units is not the depreciation amount per unit. So we now need to work out between D and E, which is the best option there. So what we're looking for is this value of D. Okay, so we know that the machine produces 24,000 units each year, and after 3 years, so it's done that for 3 years, we have a value of 18,480. So the difference between our starting value of $30,000 and the value after 3 years, 18,480, divided by the total number of units produced in that time, that will give us the cost per unit, the depreciation per unit. Okay, and so when we calculate that, we get 0.16. So 16 cents per unit, that gives us our answer of E. Okay, so the next question we're looking at here is a slightly different take on how we calculate a final payment in a reducing balance loan. Okay, so we've got Joseph has borrowed $50,000 to buy a new car. The interest rate is charged at 7.5% per annum and it's compounding monthly. He will fully repay the loan with 60 payments over 5 years. Immediately after the 59th payment, Joseph still owes $995.49. What is the value of his final repayment? Now, in this case, we don't know what his regular monthly repayments are. So we have the option of finding that out and then working through like we normally would to find the value of the final payment. Our other option, though, is because we know how much he owes after that 59th payment, we can use this $995.49 as our principal value. So that's our starting point. We're going to make one final payment, which means our N will be 1. And we can know that our future value, we want that to be 0 so that our loan is paid out, and we can solve for what is our payment for that particular scenario to occur. Okay, so if we jump into our calculator now and putting in the inferred information that we do know. So what we're saying is we're going to make one final repayment here. Okay, so we'll make N1. Our interest rate, we were told, was 7.5% per annum. Our principal value, so at this point he owes, so we put it in as negative $995.49. We want to solve for the payment. Okay, so we'll come back to that. We want our future value to be 0, so we don't want Joseph to owe any more money, and he's making monthly repayments in monthly compound periods. So when we come back and solve for our payment value there, we get $1,001.71. Okay, and coming back to our question now, we can see answer C gives us that payment value. Okay, so this question, only 38% got that question right. And I think it was mainly to do, A, with a little bit of time, and B, how to attack a question like that. So as I said, we do have the option of firstly putting in the info we know and finding our regular payments, so find PMT, and then saying, well, if I'm making these payments, what still owes when N is 60, and doing my regular payment plus my future value. So I would do that if there was a bigger question where I needed that payment value for some other reason. Okay. In this case, though, because we're told just so let the value after payment 59 be our principal value, then we can use this to solve for PMT when we make one more payment, so when N is 1. Okay, so that's a different way of approaching this question, and probably the most likely reason why it was poorly answered. A lot of people may have just had a bit of a guess. Okay, what we should know is that it's not going to be exactly the same. If they're asking you a question like this, you can say pretty safely it's not going to be the same payment that is made all along. Okay, so the next question here, again, we need to use our finance solver first. There's a two-part question here. So Millie invested $20,000 in her account, and we have interest compounding monthly. Okay, so we've got a PV, and we know it's compounding monthly. After 1 year, so we've got a time frame, and the balance of Millie's account was $20,732. So our future value there. What they're asking us, though, is what is the difference between the interest rate used by the bank and the effective annual interest rate for Millie's account? So we need to find what is the interest rate, and then we're going to find what is the effective rate based on that interest rate the bank's using when it's compounding over 12 months a year. Okay, so we'll jump into the finance solver and find our interest rate, and then calculate our effective rate there. Okay, so what do we know? We know we had 1 year of monthly payments, so 1 year of monthly payments. We're going to come back and find our interest rate. Millie invested, so she gave $20,000 to the bank. She's not making any additional payments, there's no mention of that. And at the end of the 1 year, she will have, so the bank will give her $20,732,000 compounding monthly. So now we can go back and solve for our interest rate. And so there we get an interest rate of approximately 3.6. Okay, so that's 3.6% per annum that the bank is paying. Now remember, to find our effective rate, we're going into our finance menu and we're doing interest rate conversions, and we want to find an effective rate. Okay, we put in our interest rate, 3.6, and then the number of compounding periods per year is 12. So we have an effective interest rate of 3.66%. Okay, the question though wants the difference between those two. And so we have approximately 0.06% difference between the two. Okay, and so with our difference, we can see B is our answer there. Again, 51% got that right. Some would have guessed, some would have been quite happy to work that out. And it's a way of using your finance solver effectively to find that missing piece, so that then you can calculate the actual answer that's required. Okay, we're moving into some exam 2 questions now, and jumping to question 7, we've got a bit of information here, and then we're going to jump to part D of that, because that's where it started to get a bit more difficult. So Phil is a builder who has purchased a large set of tools. He's depreciating these tools using the reducing balance method. The value of the tools can be modelled by the recurrence relation shown. Okay, so I've just given you that information because we need to know some information about what our initial cost, so $60,000 was what he paid for the tools. But in part D, they're saying he has another option for depreciation. He's going to use the flat rate method of 8% of the purchase price per annum. And so we want to now write down a recurrence relation to model that. Okay, so with your flat rate, what we need to remember, we're always having our initial amount, n plus 1 will be Vn minus our depreciation amount. Okay, we calculate our depreciation amount by doing our initial times our rate. If there is any compounding or any breakup of that, it's not annual, we do over n, but then over 100. So in this case here, first thing we need to calculate D. So our initial value of the tools, 60,000, times our 8% of the purchase price, our flat rate. And so when we do that, we get $4,800 as our depreciating amount. And so now we can put that together into our recurrence relation. Okay, be very careful that we're using the correct variables that they're telling us. We have our initial value of 60,000. Vn plus 1 will be Vn minus 4,800. Okay, so that question was not well answered. A couple of things that could go wrong here is not using the correct notation, not showing it as a recurrence relation, but rather a general rule, or mixing up the two sets of notation. You need to be really careful and really clear as to which version of the rule is required. Okay, moving now on to a different question. So in question 8, Phil invests $20,000 in an annuity from which he receives a regular payment. So he's made an investment of $200,000 and he's withdrawing off that. We can see that the recurrence relation here is modelling that situation. So in part B is asking you to show that the annual percentage compound interest rate for this annuity is 4.2%. Okay, the important thing here is the show that. Students tend to struggle with this type of question. So your annuity, show that question, you must set up an equation with an unknown value in it. Okay, it must be an equation, not an expression, so it has to have an equal sign. So what we would normally do to find this R value, remember R would be, in this case, it's an investment, so 1 plus the rate over the number of compounding periods over 100. So we need to use that formula and set up an equation. Okay, so we know the big R value is 1.0035. That is equal to 1 plus what is the interest rate? Compounding monthly, so over 12 over 100. So here we've set up an equation that has that unknown interest rate in it. What you cannot ever do, never, never, is use the 4.2, use the answer in your setup. Okay, you need to pretend you don't know it. That's what the point of a show that question is. Okay, now depending on what year it is in the exams and what the examiners are looking for, that may not be enough. You have to show some manipulation of that equation. Okay, so here we would subtract 1. Okay, so we can say that 0.0035 is equal to R over 12 over 100. Okay, and then we might also do a bit of manipulation here. So to get rid of the divided by 100, we would times by 100. So we'd have 0.35 equals R over 12. And then again, multiply by that 12 gives us 4.2 equals R. Okay, so here we've shown all of the steps of working required. Now, obviously, you're using your calculator off to the side to do those little calculations, but you need to show some steps of that working there. Okay, at very least, very, very least, this first step is an absolute must. That might be enough to get you 1 mark, but it may also not be. So you have to be prepared to try and do a little bit more work, even if algebra is not your strong point there. Okay, so looking at part C now, We're told here at some point in the future that annuity will have a balance that is lower than the monthly payment amount. Okay, so firstly, the monthly payment amount we can see from our equation or our occurrence relation up here is $3,700. So what is the balance of the annuity when it first falls below the monthly payment amount? So firstly, we need to know when. So when does this happen? So we're going to find N. Okay, then we'll use that value of N to find out what the balance is at that point. Okay, so coming across to our finance solver, we're going to find this value of N. Okay, so firstly putting in what we know. We were told the interest rate was 4.2%. He has invested the $200,000, okay, and getting a payment, so a positive value, taking out $3,700 every month. We want a future value at this point to still have $3,700 in there. So we put it in as a positive $3,700, and we find out how long it takes to get to that point. So when we solve there, we get 59.02 payments. So 59 payments, there would still be a little more than 3,700, but at 60 payments, there'll definitely be less. So let's make N 60 and now find out what our future value is after 60 payments. Okay, so after 60 payments, we would have $92.15 left in the bank. And so that's what our question is asking us for. Be really careful with your rounding in any of these questions. I would recommend writing down what you got in your calculator, okay, and then giving your final answer rounded off. So we found when N is 60, we ended up with a future value of 92.1532. And so that means he would have $92.15 left. Remember, always round to 2 decimal places when you're working with money. Okay, so this is continuing on from Phil in question 8. If the payment received each month by Phil had been different amount, the investment would act as a simple perpetuity. Okay, so what would be the monthly payment if this was a perpetuity? All right, so key thing here, if it's a perpetuity, our payment amount is given as D, and it's always our initial value times our rate over the number of compounding periods over 100. So it's just that part after the decimal point of the R value from previously, or we can work that out again. So we know Phil invested, so our V0, $200,000. The rate was 4.2%, compounding monthly over 100. And so when we calculate that, we get $700 as his monthly payment amount. So quite different, but it means because it's a perpetuity, the investment amount is the account balance remains stable. Okay, new question. So Phil is going to purchase a block of land. He's going to borrow $350,000 to make his purchase. We have an interest rate of 4.9% per annum compounding fortnightly. Okay, so remember that means 26 payments and 26 compounding periods in a year. After 3 years of equally fortnightly payments, his balance of the loan will be $262,332.32. What is the value of the payment? So we need to find PMT. Okay, so let's jump to our finance solver and put in what we know. This question will seem familiar because we have done it before, but it's worth just running through again. Okay, so we said we've got 3 years of fortnightly payments, so 3 lots of 26 payments. Our interest rate was 4.9%. Phil borrowed, so positive $350,000. We're solving for what his payments will be, so we'll come back to there. And he, after 3 years, he owes, so negative, $262,332.33. Okay, we do need to adjust our payments, so make them fortnightly, 26 times per year, and then we can come back and solve for our payment. So Phil is paying $1,704.03 per fortnight. Okay, so if this was my actual exam paper, I would actually write down what I had in my calculator for all of those values and indicate that I solved for PMT, for the payment, and make sure that my final answer is given as required to the nearest cent, so 2 decimal places there. Okay, so continuing on the last part of this question. So what is the total interest Phil will have paid over the 3 years? So remember, your total interest, okay, is what you paid, so the total paid minus the principal reduction. Okay, so the total paid, we need to work that out first. Total paid will be, you were making payments of $1,704.03 for 3 years fortnightly. So you can put that in as 78, or we can just put it in like that. Okay, so the total amount paid, $132,914.34. Okay, our principal reduction will be the difference between the starting balance and the balance at 3 years. Okay, so let's do 350,000 minus 262,332.33, and we get $87,667.67, and so therefore our total interest will be the difference between those. So 132,914.34 minus 87667.67, and there we get our total interest at $45,246.67. Okay, and the very last question, and this is the very last section in this module last year as well. Over the next 4 years of his loan, Phil will make monthly payments of $3,517.28 and will be charged an interest rate of 4.8% per annum, compounding monthly. So let BN be the balance of the loan and write down a recurrence relation. Okay, so we need to take all of this information we've been given here and write down a recurrence relation. So this is from the point of after these 3-year period. Okay, so he starts with his initial amount will be the 262,000, so on. Okay, not the original 350. And so the first thing that we need to do in order to write it into this form, we're going to have it of the form B0 Bn plus 1 equals our R value times Bn minus our payment value. Okay, so the only thing we don't already know is this R value. We need to calculate that first. All right, so R is 1 plus the interest rate of 4.8 compounding monthly over 100, and that gives us our value of 1.004. And so now we can put that together. So as we said, our initial value is that 262,332.33. The balance in the next month will be our R value, 1.004 times the current balance and minus the payment of 3517.28. That was worth 2 marks. Sometimes the mark will go to calculating the R value. It may have been giving the correct initial value, but there is definitely at least 2 components there, putting it together and calculating a value. This question wasn't done very well at all, and I know when you first looked at it earlier throughout the term, you found it challenging too. It's about time, but because there is also a lot of information there. But the processes involved are actually not that difficult, and you will expect to see them, but it's just being able to decipher that information under that exam pressure. Okay, that's it for the 2019 exam review. Hope that was helpful.